This time calculation generally, I mean, absolutely, time is just a quantity which is just like a space. So it just keeps on moving. But for us, time has got a specific meaning in terms of days, nights, change of weather, and so on and so forth. So we will understand the motion of Earth and the solar system. Then how night and day comes, and what is the reason behind change in weather. And when it comes to calculation of time in terms of sunrise, sunset, moon, noon time, and different locations of the earth. So how it changes, how it is calculated mathematically, those kind of thing we'll understand. And finally, we'll also understand like different time zones on different location on earth. Uh, and Also like what is the convention of calculation of time zone at different location on earth, and some history behind it. So this is kind of an overview of the today's discussion. And you can, I mean, I would like to be interactive. So if there is any question at any point, just you can simply ask or put in comments. So Abrar bhai will take care of that. So we'll attend that time only. So it is very interesting topic. Let me tell you upfront. And you will enjoy a lot of concept related to time, weather, and then uh, motion of Earth. It will be very clear. So I would like to say like stay tuned and be interactive. Okay. So if you are okay, just say thumbs up. Thumbs up. Great. So let me go ahead. This is our solar system. So solar system is basically defined like there is a sun and there are planets. So these are the planets, and along with the planet, there are a lot of other bodies which we do not generally even account for it. So after the sun, the nearest planet is Mercury, and then after that we have uh, Venus, and then Earth. So the Earth is the third one, and after that we have Mars. So the neighbor of Earth is basically Venus and Mars. So that's how um, we have gone to Moon, which is a satellite of Earth, and then we have also gone to Mars. So this is what we have done, and there are different explorations by NASA where they have sent some. Um, missions on different planets also. So that is very interesting thing. Maybe in some other time we'll discuss about those interesting findings of different planets. But for now, let us go ahead with that and let us have some kind of a sense like what are these bodies. So this is the sun, and if you simply do a visual comparison of different planets with respect to sun, so you can see this is your Jupiter and this is the Earth. So we are almost like a dot in front of, you can say football. So a football and a dot. So that is the comparison between Sun and Earth. If you try to understand like how far they are from Sun. So suppose we travel from Delhi to Mumbai by some aeroplane, then it takes about 2 hours and 5 minutes. And distance from Delhi to Mumbai is 1,148 kilometers. So it takes 2 hours to travel 1,148 kilometers. So suppose you travel with the same aeroplane, hypothetically, which is not generally, it is not possible, but hypothetically, if you travel using the same aeroplane, and you have to travel from Sun to Mercury, then it is going to take 11.5 years. From Sun to Venus, it is going to take 21 years, and to Earth, 29.8 years. And to Mars, it is going to take 45.3 years. To Jupiter, 154, and Saturn, 283, Uranus, 571, and for Neptune, it is going to take 895.5 years. So these, I mean, this is just for a comparison, which actually gives kind of a sense that how far these bodies are from the sun and from each other. So this is the distance in kilometers, in case you are interested. This is million kilometers. So for Earth, so just to simply remember, it is 150 million kilometers uh, distance from Earth to Sun, which is called astronomic unit 1. And other distance from the Sun to other planet, this is compared with respect to that unit. So for Mercury, it is 0.39 and Venus is 0.72. Don't remember all these numbers and don't worry if you don't, if it's not making any sense. I'm just trying to give you some kind of understanding how far these bodies are from each other and what is the size of these bodies. So the nearest satellite for Earth, we have only one satellite, which is called Moon, and it is quite close body from Earth. So the diameter of Earth is 12,800 kilometers. So, but the diameter of Moon is just 3,500 kilometers, which is almost 27%. So, for remembering purpose, you can simply say it is just 1/4 of Earth. It is very small. And the distance of Moon from Earth is 3.844 million kilometer, 0.384 million kilometer. So this is the distance of Moon from Earth, and it takes about 27 days by aeroplane. So if you want to travel by aeroplane, it is going to take 27 days. So we have Moon, which is very small, just 1/4. So suppose if you want to do some comparison of the size, so if you see on our map, it is just little bigger than Russia. So this is how the size of Moon. So it's very small as compared to Earth actually. And recently we have one very great successful mission to Moon, which is called Chandrayaan by now, ISRO. And earlier, like other countries, America, Russia, they have sent their mission on Moon. But India successfully landed on Moon, and that to South Pole, which is one of the very difficult tasks to do. So this is what we have done. So it is not like a straight flight. You start from Earth and then simply like aeroplane, it goes directly from Earth to Moon. So we have taken this route, and the purpose why we have taken this route is here we are going to spend a lot of time, but the benefit is you are going to spend a lot, very less energy, and basically less energy means less cost. So that's why the cost of our Moon mission was, if you calculate in per kilometer basis, it is cheaper than what we pay to our rickshaw. So it is much cheaper than that. So that's what it is, and that's why this is very famous. So we launch our mission from Earth through a launcher, and the job of the launcher is to take the satellite in Earth's orbit. So this is the first orbit, and this is done by this launcher, which was done on 14th of July 2023. And after that, when it reaches to this location, that is called PG, and this is called apogee. So when it reaches at this point, there is a booster which will increase the speed. As a result, what will happen? The orbit size of the orbit will increase, and this happened in a series. So as in all the this motion, when it actually approaches at this point only, then only the booster actually works. After that, there is no booster applied, so there is no loss of energy. It's just moving around with the gravitational force. So that's how we have done a series of operations. And after that, at this point, when the booster was applied, it actually left the gravitational field, and it went to this Moon gravitational field. And when it reaches there, the job of our people is to reduce the speed. Otherwise, it will simply cross this. It will not be bounded because it is coming from far field. So the thing is, if something is coming towards a mass from very large distance, it is not going to get bounded in the orbit. It will actually leave the orbit. And the path is called hyperbolic. So they have to apply kind of a brake. So it is just the reverse of thrust. It will be applied. So the speed is slowed down. And again, same thing, just inverse of this is done here. Every time they have to put a against thruster. So essentially it will start from here and then it will go there. So there also we have taken a lot of round of the moon. And then when we are trying to land, again, we have taken a lot of round just to find a correct position and time and the location of the sun also, so that the site where we want to land, it is in sun. It should not be dark. So we took a lot of time to just wait for it, and then finally we landed. So this is our Chandrayaan mission. In short, there are a lot of details about the Chandrayaan. I will share all the links which we are going to discuss here at the end of the presentation. So let us explore the Earth from the Google Earth. So I am pretty sure you know Google Earth, and we have played with Google Earth a lot. But just let us play once again. So this is the Chandrayaan detail. If you are interested, I will share the link. All the details of the Chandrayaan, different modules, and then our lander, everything is, all the details are given on this page. This is ISRO official page. So all the details are official details. This is our Earth on Google Earth. So it is very interesting. I mean, if you spend some time on this, then you will have a very fair sense of the different countries and their location, relative locations, and you will also understand the directional sense of different countries. So we start with, like, this is our India. So this is India, and then this is our Saudi Arabia, this is Africa, you know. So one very important thing is, suppose you are somewhere on Earth and you want to understand, like, okay, I want to know what is the direction of Saudi Arabia from, say, for example, India, or what is the direction of Saudi Arabia, say, for example, Greece. So it's a very, very important question, and it is very much required by pilot who is driving airplane, or also for our purposes when we want to pray. So every time you have to face towards Qibla, and how to understand, like, what is the direction of Qibla. So this is, I mean, it gives you a fair understanding. For India, it is mostly towards the west, and for other countries, it will change. Sometime it will become east, sometime it will become west, sometime it will become north. So depending on where you are on Earth, your country or location, it will change. So now coming back to our presentation. So you'd have heard of International Space Station. So this is a space station is kind of artificial satellite of Earth, which is created by human being, and it is very near to Earth. So again, like, if you want to have some sense of what it is, so there is a website on which, if you simply type International Space Station, so they will give you live location of International Space Station. So right now it is somewhere here, and they will show different cameras. So they have camera mounted inside, outside. Sometime what they do, some kind of a repair work. So yes, some kind of a repair work. So astronaut, they are working, so you can actually see they are working. And many times you just point the camera over Earth and you can see, like, different seas, different countries, and so on and so forth. So they do a live streaming of from the International Space Station, um, and different countries, they send their scientists on this, and then they stay here for about 4 months and then come back to Earth. So this is, like, very, very important for conducting different experiment where the effect of gravity is causing any problem. So you can see in this picture, this astronaut is kind of doing some kind of a repair work of this station. So this is also very interesting. I mean, just spare some time on International Space Station. So I was discussing about Earth, and we have seen Earth on Google Earth. But when it comes to maps, so these map we have seen in school, and it is printed in our this, textbooks. So we see this map like this, the one in the right. But actually the map is like this. Okay, the one in the left. And there is because of this, I mean, we move from a kind of a spherical shape to a rectangular shape. There is something, you can say, changed. So, for example, the length of Russia, you can see, is huge. Actually, Russia is not that big. It's small, actually. These countries, they are shown very big, but they are small countries. I mean, you can simply do comparison. This is this country, but here it is big and here it is small. This is this country, but here it is showing small, here it is showing big. Why it is happening and why we need to do all this kind of thing? What is the purpose? So essentially, see, our knowledge is basically through books, and books are printed on papers. So actually, you can print anything on paper which is two-dimensional. I mean, having only length and width. Anything having third dimension like height and so on, you cannot simply print on paper. So for that purpose, you have to take the sphere and then convert into a rectangle. So how it is done? This is called mapping. So this is a mathematical technique where you take a sphere and actually open it up. So what you do is simply from this top to bottom, you cut. Okay. And then for this, you simply all the lines should go and map onto a cylinder. So essentially imagine there is a cylinder wrapped around a sphere, and then there are lines drawn on the sphere and the cylinder, and the corresponding points from the sphere are mapped to cylinder. So that's what it is. So once you map and then cut the cylinder from one side, lengthwise, and then open up. So cylinder, once it is cut and open up, it will become a rectangle. So this is how it is. So that's how we actually create from spherical to rectangular shape through a cylinder and mapping. And in the mapping process, you can see this point, they are actually joining together. But when they are projected on this cylinder, they are very far from each other. And that actually causing the stretching of those areas which is near the pole, both South Pole and North Pole. And this actually creates this distorted images. They are not actual. They are actually, because of the projection they have come. Actual is this. Okay, so we have seen like whenever we say globe, we see those lines which is actually running from one pole to other pole, and also which is running across. So the one which is running from one pole to other pole, it is called latitude. So just to understand and remember, suppose you are sitting, and also for the simplicity purpose and for the discussion and calculation, let us assume the Earth is perfectly spherical. So suppose you are standing at the center of the sphere. So you are just looking, sitting here, standing here, and you are looking at this point. So you have to look above or below. So since you are looking above or below, basically you are either going down or up through your eyes. I mean, your eyes are either going up or going down. So essentially, you can connect that this is kind of related to latitude. So latitude is rhyming with altitude, which is meaning height. So you can remember this latitude is some way connected to altitude, which means height, meaning your eyes are moving up and down. So there is a sense of height here. The one which is running like this at different latitude, you have circle around the sphere. So they are called longitude. So these longitudinal lines, and then these are the latitude lines. Why they are required? Basically, in a spherical coordinate system, in geometry, if you want to specify any position on the sphere, how to do that. So this is the way through which we can actually very precisely identify different location on Earth. And that's how our Google Map and other devices, your computer, your mobile and everything, they actually have a GPS in your device. And from the GPS, it actually calculates these coordinates, latitude and longitude. And from this coordinate, you can actually very precisely say where you are on the Earth. So these two numbers are more than enough to specify your position. And that's how we have all the addresses, locations, cities. They are mapped to this coordinate system to the address, which is called geocoding. So Google has done great work in geocoding. Essentially, if you give me your location, I can tell you the address. Or else if you give me the address, I can tell you the location. Knowing this actually is very important because from there you can go into mathematics and do a lot of calculations. So we'll see some of the calculation using this coordinate system. Now there is a challenge, there is a problem. Here you have one pole and this pole. So basically this this is plus 90 degree and bottom is minus 90 degree, and you can take this horizontal as 0 degree. However, if you are moving from this point to that point, meaning longitudinal, if you are moving, there is no start and there is no end. So where to start? That is the point. So then people have come up with this kind of discussion, and they agreed onto some location on Earth as a starting point, and this is named as a Greenwich meridian. So which location should be terms as a Greenwich meridian? There is a basically, you can see whenever there is a discussion and we need some agreement, then basically whoever is having power, they will actually overpower all the other decisions, and then everything will go in their favor. So we'll see how this happened, this Greenwich meridian. So essentially, again, if you open up using the same procedure from the sphere to a rectangle, so this is your prime meridian. So this will be 0. And from here, this direction is 0, 30 degree, 60 degree. So everything is like 15 degree, 30 degree and 45, 60 degrees, this direction. And from here it is equator. So it is 0 degree. And again, up if you go 15, 30, 45, 60 degree, and down you go again 15, 30, 45 degree. So essentially entire Earth is now given a coordinate system, and then each and every point on the Earth can be specified by this. The 0 on the Earth is prime meridian. So there is an international agreement that the meridian that runs through the Greenwich, England, is considered the official prime meridian. So this prime meridian is actually running through Greenwich. This is a location in London, England. So from here there is an observatory. So it is actually, this line is passing through that observatory, and this is termed as a prime meridian. Okay, so when this happened, actually, it happened in 1884. So there was an international conference in Washington DC. So what happened in 1870? I mean, in 1860 to 1870, what happened? We discovered telegraph. Okay, and we started sending messages from one country to other countries. I mean, through seas. So we laid down cables from one country to the other country, and we started messaging. However, so we actually solved this messaging problem to a great extent. So it is almost instant. We want to send a message from one country to the other country through this telegraph systems, you can actually send. But the problem was, like, in your country, it is morning, and the country where you are sending, it is maybe midnight. But you don't know actually, because there is no convention. There is no there is no idea. How do you know that the country where you are sending a message, it is midnight? Because there is no common agreement on time. You know that it is day in your country, it is morning in your country. So and also like accurate determination of marine position, and there was no worldwide agreement on the meaning of these temporal and geographical coordinates. So essentially, the problem was both, like where this location is. Suppose you are having, you are in a ship, so location and time both is important. So we need some kind of an agreement worldwide where this coordinate system, latitude and longitude, and the time, this is agreed upon, and so and all the locations are calculated, so that sitting in one country, you know exactly like in the other country it is morning, evening, afternoon, whatever it is, you exactly know. And if someone gives you the coordinate system of their location, you know exactly where the person is, what is the distance and what is the direction and so on. So this happened in 1883 in Washington DC, and then we have seen like this is what it is agreed upon. Greenwich will be zero meridian, and then entire globe was divided into different time zones. And then after that, it was given to the countries, like you can decide like what should be your time zone. But the thing is, like you should be, since you are falling in certain time zone as compared to Greenwich, you have to decide like maybe in between. You cannot say like, okay, I am falling in say +5, but I will say it is -5 and so on and so forth. That is not possible, but you can do. So India, we have done something like that. So we'll see like what we have done, some minor corrections just to maintain a single time zone in India. Otherwise, by convention, India should have 3 time zones. So yes, this is prime meridian, Greenwich meridian, uh, we call it. And there is an observatory and there is a line. So you can see this is the picture of the line in Royal Observatory. So this line is your zero longitude. So from one side it is positive, and the other side it is zero. And here it is like if you do time zone calculation, so it is 0 GMT. So from here, if you move left or right, your time will increase or decrease, depending whether you are moving left side or right side. So this is the convention, and this is what you have agreed upon. Let us now look at like what is the direction calculation. So I have been saying like you can do calculation of direction using this coordinate systems. Let us do like suppose you are in New Delhi, for example, and you want to pray Salah, and you want to know like where should I face. So you know like your coordinate system. So Delhi has this 28.7041 north and 77.1025 east. And Saudi Arabia, this is the city of Mecca. So the city of Mecca has this coordinate system 21.3891 north and 39.8759 east. So east is basically longitude and north is basically your latitude. So that's how it is written in short. So we have to do calculation, and so basically it is making a triangle, and you can do some kind of a angle calculation. But the problem is trigonometry in spherical coordinate system is very different than trigonometry in plane. So for those who don't know, like what is the significance of Mecca and Saudi Arabia? So this is the picture aerial view of Masjid al-Haram. So Masjid al-Haram is the masjid around a cubical shaped building which is called Kaaba. So for Muslim, it is mandated that whenever they do Salah, they offer namaz, they have to face towards the Kaaba. For those people who are inside this building, which is called Masjid al-Haram, so they know there it is mandatory that they exactly face this building, the cubicle shaped building, which is called Kaaba. And for those people who are in the city, other part of the city, for them it is um, not mandated to exactly face that building, but towards the Masjid al-Haram, it is more than sufficient. If they face towards the Masjid al-Haram, it is sufficient. And for people like us who are very far from the city of Makkah, for us it is more than enough if you simply face toward the city. That is more than enough. So, I mean, this much of accuracy is required in positioning yourself while you are offering salah. So this is the significance. So as I said, like the trigonometry in spherical coordinate is little different. So this is the formula to calculate angle from one point to the other point using this coordinate system. So sorry for those people who don't know much of mathematics. So it is just for presentation purposes. This is very simple formulation, but it gives you exact direction. So you can simply calculate this and you get this number to 166.52 degrees. And I am showing this comparison with one of the online calculation platform. So they have done this calculation. They are showing 266.60. So I'm just trying to say that it is very simple, and the calculation is very simple. You can actually write this code if you are a developer or something like that, and if you want to understand, this is how it is done for some educational purposes. But there is a catch here. The catch is actually we are talking about geometry, but there is no way actually how to know like what is the direction. Meaning, you know this from the north, you have to tilt by 266 degree, rotate yourself from north. But for first time, you need to understand where the north is actually. So to understand where the north is, we use magnetic compass. And magnetic compass works on magnetic field, Earth's magnetic field. But there is an assumption that Earth magnetic field is showing north. But what we want is the geometric north. So the thing is whether the geometric north and magnetic north is same or different. But the answer is they are not same. There is a difference of 11.4 degrees. So 11 and this magnetic north, they keep on changing with time. However, the change is very small, but it changes. And in recent past, it has changed a lot. So it is very important for us on a day-to-day basis, it's not going to affect our life. But for other people, for example, a pilot, for them, understanding the direction precisely is very important. So suppose they are in flight and the north changed, I mean, they will be misguided. So a lot of calculation happens using this magnetic field of the Earth. If it is changing very rapidly, then we will have a lot of problem in doing those things. But for a daily life, it's not going to affect us. So this is how it is. This is geometrical north, basically, and this is the south magnetic pole. So south of Earth is north of for us. So that's how north for Earth is south of. So that's how it is, because the north of the magnet is attracted towards the south, and south of the magnet is attracted toward the north. That's how it is. But if we are on near the equator, we are not near the pole. The change in this geographical north and the magnetic north is actually very minor, less than 1 degrees. And for all practical purpose, especially for Salah, it is not going to create any problem. So the formula that we have used is good enough. We can use it and then we can go ahead. But for other people, like they want very, very precise calculation, they have to actually take care of this change and then do further corrections. Let us now try to understand the solar system once again. This time we are going to see like how the motion of Earth happens around the sun and how it affects our morning, evening change in weather and so on. So yes. So this is another website by NASA. They call it eyes.nasa.gov. It is very, very informative website. So they are showing live position of different uh, uh, different bodies, like they're showing Mercury, Earth, Venus, and so on and so forth. And they have a lot of other things like total solar eclipse, asteroid and comet mission, entry, descent, and landing. And they have this Voyager. Voyager was actually sent in 1977. It is still in space and it has gone into another, it has left our solar system and gone into some other solar system. So this is one of the grand mission by NASA. So let us quickly explore this. This is very, very interesting. So what this is live. So whatever is happening is live. So you can see like there is no motion. So what I will do, I will try to accelerate this. So here it is 40 minutes is equal to 1 second. Now it is 6 days is equal to 1 second. Now you can see I have increased the speed. You can see now everything is happening very fast. So just look at the Earth. So this Earth is moving. The orbit of the Earth is this one, the green one, the blue one actually. Yes, this one. So this is Earth is which is moving. One thing there that we have to notice is the the path that Earth is following. It almost circle, but it is not actually circle. But others they are not following that perfect circle. So they are little eccentric, or you can say oval shape. So maybe you can take your time and play with this. So this is how it gives you some kind of idea, how motion of different bodies around the sun happens. And suppose if I take Earth as a center and then rotate it everything. So I have taken Earth as a center and trying to see like how others are moving around this. So you can see when you keep Earth as a center, meaning you are sitting on the Earth and you want to see like how others are moving. So you can see like, okay, sun is moving around the Earth and that's how morning, evening, everything happens. And like sun, other planet also move around the Earth. So, I mean, depending upon their situation where they are, sometimes we see some of those planets in the sky, and some many other time we don't see them. So, I mean, it is very complicated motion, but I am just showing it for some demonstration purposes. So, you simply play with that, and it is good. So, this is how it is. So, actually, Earth is moving around the sun, but since we are on Earth, so wherever we are, for us, since we are sitting on Earth, for us, Earth is stationary. Rest of the things are moving. So that's how we see like, okay, sun is rising and sun is setting, but actually it is Earth which is moving. Sun is not. Sun is moving, but sun is moving around something else, not around the Earth. And as I said, like the trajectory that is followed by the Earth is almost like a circle with little eccentric, like oval shape. So the distance we have seen like it is 150 million, but it is not exactly 150 million. At some part of sometime like around January, it is very small, and then around July you can see it is little larger. So in January it is 147.3 million, and in July it is 152.1 million kilometers. So it changes from one time to other time. So that's how it is. Two things. One, when we are here, it is called December solstice, meaning on 21st or 22nd of December, the day will be smallest, and the night will be largest. And when we are here in June, so on 21st and 22nd of June, you will see like your night is smallest and the day is largest. So this is one, I mean, knowledge people ask like in exams and all, like when the day is smaller and then when the day is larger and so on. So this is how it is. But one more thing, like it's not like simply Earth is moving around the sun, but it is also rotating around its axis. So moving around the sun is one thing, and then rotating around the axis is another thing. There is one more thing. While it is rotating around its axis, the axis is not vertical; it is tilted. tilted by some 23 degrees. So just give some kind of a number, like when the Earth is moving around the sun, the speed is 107,000 kilometers per hour, which is about 20 times the speed of the bullet. And the bullet, the fastest bullet that we have developed till today is, and the speed of the bullet is 5,400 kilometer per hour. So the Earth is moving around the sun at a speed which is 20 times the fastest bullet speed. So this is the speed at which it is moving around the sun, and while it is rotating, again it is very fast. We'll come to that. So this is what it is actually. So the sun is there. It is not to scale. This is just to demonstrate like what happens because of the rotation of the Earth and tilting of the axis. So what happens? We see sun from the location where actually we are on the Earth. So in this position, when the Earth is in this side, the axis is tilted like this, and the Earth is rotating. Okay, the Earth is rotating, but the axis is tilted like this. So what happens? Um, in this region, that is the South Pole region. Okay, mostly the December, January, and this time, when in the northern region we are having winter, the south region they will be having summer. So you can see like this entire pole area is having sun. So in this area, in this region, I mean this time frame, they will not have light. They will not have nights. Only light will be there throughout the year. So I mean throughout the month. So there is no sunrise, sunset, everything. I mean, there is nothing is there. Wherever in the northern hemisphere, you can see this area, they will not have any sun. So they will be in dark. So right now this area will be in dark. A lot of cold will be there, and this entire area will be having cold. But this area will be having sun, and this will be summer season for them. Now going back to this other time of the year, that is June. So in June and around that time, you can see this northern hemisphere. It is facing towards the sun. So we'll have summer. This region will have summer here, and opposite to that, this region will have winter, and this pole will have only day. There is no night. So there is no sunrise, sunset, nothing is there. So this is the effect of tilting of the earth, rotation of the earth. So rotation of the earth causes sunrise and sunset. The tilting of the earth is causing the change in weather. If there is no tilting, every location will experience same kind of sun all the time. There is no change in weather, or all the weather together. I don't know really what will happen. So the nice change in weather like summer, winter, everything happens on earth is because of the tilting of the earth and rotation of the earth. So okay, so because basically this is one idea how to basically simply understand this. So if you do one thing, suppose the earth is not moving, just for understanding, and sun is moving. That is one part. And let us say that, okay, earth is also not tilted, it is just rotating. But actually the path of the earth, path of the sun, sorry, the path of the sun is this plane is tilted. So we simply say, like, instead of saying earth is tilted, let us say the plane of the sun is tilted. So this is the path of the sun. Okay, this is the path of the sun, and this is the you can say plane of rotation of the earth. So this is the plane of the rotation of the earth, and this is how the sun is actually moving. So we'll see, like, okay, at different time location on the earth at different time of the year, how the sun is rising and where it is the sun is moving. So basically the idea is, let the sun move, let the earth be stationary, and let we sit on the earth, and let the change of the rotation of the earth is actually equivalent to sunrise and sunset. So what will happen? So let me again show one demonstration here. So this is very nice map of the earth. it shows like where is the daytime, where is the night time. So I'm in India, so it is showing Delhi. So Delhi has a almost noon time. It is about 11:51. So noon time. You can see this region. So basically, Earth is moving like this, and or else you can say the sun is coming like this. So this region, we are having afternoon here or noon here. This region is having morning. This region is having morning. So basically, sun is going like this. So they have sunrise in this region. Then there will be these two lines are showing different angles. And then here there will be like just morning happening there. Okay. And these people here in this region, they will be having evening. So there in this region, there is a sunset happening in this region. And then these regions here are completely in dark. So they are, for them it is night. So suppose if I change my time, so what will happen? So you can see like as I change my time, the day is actually moving. This location of the sun is moving and day is moving. Okay. And if I change the location, if I change the month, so you can see as I change the month, the region on top, you can see the region on top, they are changing because the location of the sun is changing. Okay. Right now the sun is here, and if I change like this, so if I change, the sun is here right now. So if I change, you can see. Can you see? The sun is moving. The sun is moving. As we the same time, the same date, everything is same. Only the month is changing from January to December. Then location of the sun that is seen by those people in the afternoon is actually changing, and it is actually moving in a path. So what is that path, and why they are moving, and what is that called? We will see next. So it is little complicated, but this is what it is. So you can actually, will share the list, the link of this. So you can see like how this day night is changing. But for us, suppose we are sitting somewhere on the surface of the earth, and this is west and this is the east, and then sunrise will start from here. As we move from one month to other month, starting from January, February, March, April, May, June, and again back, you will see like sunrise in January is happening from this point, and if in the afternoon is defined like noon is defined like the shortest shadow length. So if you monitor the point where the shortest shadow length is happening, and if you try to trace it, you will see like shadow length in the noon is changing from one month to other month, and it keeps on changing in a pattern. So this is what it is. Uh, Someone is standing, and this is the noon time. Okay, the sun in the sky is actually following certain path, almost like eight shape. So this is eight shape path. It is moving, and the shadow is changing with the date. I mean, what is the month and date? It is changing, and if you look at the tip of the shadow, it again creates a shape. So people in the past, they have actually done experiment, and they have actually conducted experiment number of years together. Every day they actually sat down, they kept on looking at the shadow, they plotted the dots, and then finally they come up this kind of thing. So why it is happening is, we have seen like there are two main reasons. One, the orbit is eccentric. I mean, it is not perfect circle. So because of that, there is a change in the position of the sun, and there is a effect of obliquity. So obliquity is, there is the axis is tilted. So because of the tilting also, this change happens. And these two things are coming together. So they combine together, looks like this. So minus 15 to plus 15 minutes. This is the change that happens as we move from one month to other month in the day. So this is how it is plotted. There is no problem if you don't understand it, but this is just for completion purposes. I am just showing it. So as I was saying that people have done a lot of experiment in the past and they have come up with this very nice idea. It is called sundial. So it does not require anything except the sun. So it uses the sun and the position of the sun creates a shadow. And from the shadow, people have actually divided the day in different parts, and that's how they understand what is the time of the day. It's morning, evening, afternoon, whatever it is. And before we had this digital clocks and other clocks, this was the way to understand time, morning, evening, afternoon, those kind of thing. And then many people like for Muslims, we do offer prayer in the morning, evening, afternoon. So knowing the time, like what is the time now and when to offer prayer, this was one very great means. And because of that, people have actually installed these kind of a sundial in masjids. So part of the masjid will have this sundial so that whoever is there, they will see and understand now this time is for some prayer, and then simply go and offer prayer. So basically time and prayer, they are tied together, and because the for each prayer there is a fixed time. So knowing the time is very important. That's how people have done. And I think I've taken this image from somewhere. So that particular masjid is still there. And now coming to some boring thing, this is simple calculation. I will not go in detail, but I'm just showing that using some very simple formula, we can actually do all this calculation of sunrise, sunset, and then what is the time of noon, given your location on Earth. So whether you are in India or some other country, as you change your location, your time calculation can be done, and from there you can actually know what is your sunrise time, sunset time, noon time, and so on and so forth. But right now, I mean, we have all this calculation done in some other machine, and then we have mobile devices, it is things and so on. So we don't need to really do all this calculation for some academic purposes. Someone is interested, it is good. Okay, so we have learned the time, why it is changing, and then why the day is long, why it is short, and so on and so forth, why the weather is changing. Now let us come to understanding of dates. I mean, what is the date? So for the date, again, we have some standard. So it is called ISO, that is International Organization for Standardization. It is called ISO 8601. So you have seen like a lot of things we have ISO standard. These ISO standards are for international people. So if you follow these standards, it will be there everywhere. So you don't need to have any worry like you are in India or other country. If you follow these kind of standards, especially for those people who write computer programs or website and so on, their audience are across the globe, so they have to follow those kind of standards so that everyone understands. So this is how it is. This is the format. The first four digits are year, then after that two digits of month, and then after that two digits of day. So this is the standard, the way it is written, and it is this is how it is read. Now coming to international time zone. So as I was saying, like we have divided the entire Earth into different portions. So each portion has got 1 hour duration. So basically, entire Earth is divided into 24. So that each portion will have 1 hour. Now, so basically that 1 hour is converted into 360 divided by 24, that degrees. So whichever country is falling into that region, that is their time zone. But after that, depending upon your location and your span of your country, you can redefine your time. So lot of countries, they have changed their or redefined their time zone. However, they are quite close to the calculated one. So it is not creating any confusion. So actually, it is calculated one plus some amendment on top of it. For example, India. So if you look at India, so it is India is uh, +5, +6, and +7. So you can see +5, +6, +7. So India is falling in 3 time zones. So what we have done, we have actually left this northeast region. So what we are left with is 5 and 6, and we have taken average of it. So becomes 5.5. That is 5 hour 30 minutes. So the time zone for India is 5 hour 30 minutes plus Greenwich meridian. So Greenwich meridian is for 0 here. This is the line. So I mean, for these people, United Kingdom, they have defined, and then their time zone is 0. So then they don't have to do any kind of a manipulation on the actual time. And other people, they have to do plus and minus. For example, these countries like Canada, so many time zones. America, they have a lot of time zones. So they have to adjust as they move from one place to other. They have to adjust the time zone so that they understand what is the actual time in the current location. So this is what we have done in India. I just showed. And the last thing, the international day line. So what is the international day line? So suppose you are in an aeroplane or you are in a ship. You are simply moving. For you, there is no, I mean, break because you are simply moving and Earth is also rotating. So suppose if you keep on moving in the direction of the rotation of the Earth or opposite to the direction of the Earth, so what will happen if you keep on moving? So there will not be any change in the day. So how do you calculate your day? You are in a ship. So there is this line. So if you cross this line, left side, you will have a loss of day. Meaning here you are on Monday, here you will go on Sunday. So here if you go in this direction, the right direction, then you have a gain of day. For example, here there is a Sunday and you cross the line, you will be in Monday. So basically, just by crossing this line, and this line is, I mean, there is no thickness here. So simply here it is one day back, and the next after this line you have one day next. So that's how it is. It is good for those people who are in ship and they are keep on moving from one country to other country. So that's how this international day line is defined. And then the ideally should be a straight line, but for different reasons, it is made like this. So it is there on paper. So those people who are on ship and so on, they actually use this. So with this, I stop my presentation. So I acknowledge MIPRD for giving me this opportunity and to present, and thank you all for your time and patience.
Thanks a lot, Dilshad bhai. This was very interesting. So you can have some discussions and questions if any from the audience.
Yes, I have one question, please.
Yes, yes.
So my name is Ehram Hussain. So just I wanted to know, if we have all these techniques and innovations, then why we celebrate Eid on different day in the same country? I think everyone knows about it. So for example, in Uttar Pradesh only, some people will celebrate on 15th of the month and some people will celebrate after one day. So can't we have some solution for moon sighting also? Like solar system, we have perfect date calculations. So for moon, don't we have any such systems?
Okay.
Just wanted to know.
So I mean, what you have said is little. There are two parts to this. One is helping. I mean, taking help from science and technology to understand whether there is a moon or not. That is one part of it. And second part of it, people knowing and agreeing to it. So that is the second part of it. So basically, they should be educated and there should be a consensus. So consensus and agreement is a social part, and this is a technical part. I mean, to a very great extent, there is a prediction of moon sight. However, there is not 100%. And as I said, like in all the calculation that I have shown, it's not precise. I mean, there is a error, but the error is very small. I mean, that you can manage. So many times, what happens? Like suppose in India, someone cited the moon and someone predicted it and someone cited it. If there is a agreement among the people, we will not have multiple events. But if there is a disagreement, even if the science and technology is there, people will not come together and agree on to it. It's not going to solve this problem. So I hope this answers your question. A little tricky, but yes.
Yeah, a little tricky, but at least if everyone is following science nowadays, but if science is not 100% sure, then okay.
Just to add, like, I mean, I don't tell it upfront, but just to add here, you know, Saudi government, they do not follow this spoon for their calculations. Moon is used only for Eid and Hajj. For rest of the year, their calendar is frozen, whether the moon is sighted or not, irrespective of that. So, I mean, many people do not feel good about it, but this is what it is. I mean, so practically they have started doing that. And I think
have
now they
one
have
hand-
started fixing Eid also.
One
Yes.
hand raised by Amina Lunje. You can go ahead and speak.
Yes, sir, I had a question.
Yes.
My question was that how do we understand that the Earth's axis is tilted?
Okay. So yes, this is really, I mean, it's not about axis tilted. The axis tilted problem is came very, I mean, after a long time. The first thing was like, how do you know your Earth is spherical? It's not a flat like a disc or coin. That was the first problem that actually came, and there are a lot of debate. I'm talking about some 2000 years ago. People have were having this kind of debate. So some of the scholars they have done some calculation, and I know some of the Muslim scholars they have done some experiment. So they have chosen very long field, and from the shadow of the some known length they have shown that if the earth is spherical and if it is flat, how the change in the length of the shadow will get affected. So from the geometry you can simply do calculation. You will see that if you are moving very long distance, and if you do the shadow calculation at exactly the same point, the shadow length will not be same, and it says it is not flat. And if the change because of depth, because of the length, change in the shadow because of the length, you can calculate actually. But if it is curved, it is not flat, then there will be a difference because of the curvature. So those people, I would say it is maybe around 1000 years ago, people have done those calculations, demonstrated no, earth is not flat, it is spherical. That was one problem they have solved. Then second problem was whether the earth is rotating or it is the sun which is actually revolving around the sun. So then they discovered different stars and they started monitoring them. And assuming that stars are not moving, you can actually do understand that it is not the sun which is it is the earth which is moving, because you can fairly assume that stars are at station, they are not moving. So that second problem was solved, and that's how with the help of stars people used to understand the direction and so on and so forth. The idea is like you assume that stars are stationary. Now, coming to this last, whether it is tilted or not. So then we started going towards the pole. Okay. And we have seen like towards the pole, if you go, you will see like, okay, there is no sunset, there is no sunrise, because they have 6 years, 6 month day and 6 month night. So that's how it is. And if you do calculation and try to understand, then actually it comes out that it is because of the tilting. So essentially what we do, we try to do observation and then reason out without affecting other set hypotheses and findings. So other set findings are correct. At the same time, your finding is adding to that. That's how we do calculation. And then lastly, we have now satellites. Okay, satellites are actually in the sky. So a lot of other findings that we have done thousands of years ago, it is actually validated by satellite. So satellite actually do monitor our rotation, motion, everything. And from there we do calculate amount of tilting, everything from the satellite. So satellite right now, it is the source of very, very accurate information about the Earth. So I hope this is long answer, but it answers your question.
Yes, sir, thank you.
Welcome.
Shadbhai, there are a few questions in the chat box. If you can open your chat box.
One sec. There are 9 questions. Probably I would have taken it that time only, but nevertheless. Okay. So, okay. Will also please post the link. Yes, yes. Recording. So this is to you, Abrar, right? You have to post the link of
The
it.
recording link I have
Very
posted.
informative and interesting session. Thank you very much. Could you recommend sites for understanding more on the subject? So let me do first thing first. Okay, I'm here. So there are a lot of sites. I mean, just simply do some kind of Google search. You will find a lot of them. But for now, whatever I have shown, I am sending this link in the chat. You simply copy and keep it with you. And maybe later on you can simply explore it. Okay, regarding after a few days. Okay, sir, where you will send that Chandrayaan link? Chandrayaan, yes, I have sent it here. Please share the slide deck. Okay, I need to look if something need to remove. Where should one study to learn all this from basic? Because my friend is different. I want to learn basic. Okay. So basic is essentially, I mean, there are three ways to learn. One is if you find some good teacher, you learn from that the teacher, and then the second thing is you learn through books if you are good in reading books, and third is go to websites, read the websites, and then fourth one is you do Google search and then find some good informative YouTube video. So, in frankly, there is no single answer. I do all of them most of the time. And while preparing this deck, I have read a lot of websites and also I've watched videos. And then other thing also I have done maybe a lot of calculations, other things we have just verified like whatever they are showing is correct or not. Those kind of thing we have done. So basically, these are the sources. You can also explore them. Welcome.
Are there any last questions before we close this session?
Some fact that have been proved through Quran in astronomy. This is very interesting. Who is that? Aisha Faruqi. Okay, contact detail. Okay, so contact detail. I'm just putting it here. You can copy it. See this idea. I mean, it has been there for a long time, and a lot of our scholars. I mean, very recently and also in current time and in the past also, lot of our scholars, they try to take this argument, and many times um, to make a career in this field, what should be the path? Okay, let us come to that is career thing later on. Now coming to this Quran and astronomy. Okay, so this is very interesting question, and as I said, like it has been there. A lot of our scholars, they kind of try to compare Quran and science, and with this comparison, they try to show that whatever science is finding today, Quran has already stated this some 1,500 years ago and so on. And this looks like very, very, plausible and very, very stunning kind of a statement. Wow, I mean, why we are wasting so much of time and energy? Because everything is written there. Why just don't simply go there and see it? So let me, and this is my view. Let me say like what is the actual thing, and this is my view. Someone may have other views also, and I respect everyone's view. So with this disclaimer, first of all, Quran is not a science book. So this is first of all, and any kind of a comparison of Quran with any kind of other science and technology, it is not fair. Not fair for not science and technology. It is not fair for Quran. Quran is not for that. So someone asked like why Quran is not discussing about sending moon mission and Mars mission. Why it is not there in Quran? All the details should be there so that we can go on moon and then stay there. The thing is again the answer is same. Quran is not for those people. The purpose of the Quran is not to send people on moon. Okay. Second thing, anything that can be discovered through human efforts, through intelligence, that is not the subject of Quran. Quran is something which is beyond human intelligence or human consensus. Anything where people cannot come on consensus by any means. Quran gives you a direction and follow that. So that at least you have one way to come up to a consensus. So now this is the part of the Quran. Then what is Quran? Quran is for our guidance, for the guidance of human being. So that is the purpose of Quran, why it is there, and we should all, as a human, we should all take guidance from the Quran and live a good life in this earth and in such a way that our next life is also successful. So that is the kind of purpose in Quran and topic of Quran. Now there are mentions of, so having said all these things, there are mentions of different science and technological kind of aspect in Quran. Okay. So what happens? This is just to kind of give some kind of a proof to people who are trying to find those kind of things. For example, miracles. Miracles are for those people who don't want to believe in ordinary things. They will be only believing something which is extraordinary. So for these people, there is a miracle. For those people who are very much into science and technology, how they can get affected by or impressed by Quran, then for those people, there are hints or really small thing written in couple of sentences for those people. So those who are expert in these areas and fields, they will come and read and then understand, yes, what I am understanding this after spending about 40, 60 years. Quran has just written everything in just 1 or 2 lines. It is just summarizing my 60 years effort in just 2 lines. So the greatness of writing, that's great, truthful of the statement actually gives energy, or you can say direction, to those people who are expert in those areas. So since it is for guidance, it is guidance for everyone. So for those people who are science people or technology people, for their guidance, if you are given a kind of a pointer in their language, they will understand more. For those people who are kind of in power, so there are things. I mean, those who are in power, what happened to them and so on. So those stories are for those people. And there are aspects of Quran which is for ordinary people. So basically Quran is for everyone. Everyone will find one or other aspect of Quran which is kind of close to their heart, close to their thinking, close to what they want. So, and that's how it is a book of guidance. So having said this, there is no one-on-one comparison with any science or any astronomy. Then after all, this is my view. You may have some other views also. People have been different views. They have been doing all this kind of comparison and contrast, but I am not in favor of those comparison and contrast. Thank you. Finally, to make career in this field, what should be the path? Essentially, this is a science or astronomical science or subjects. So if you want, if you find this interesting, you can actually explore those areas like astrophysics and things like that. So astrophysics people, they will do all kind of these things, exploration of space, finding out different comets, some different planets and stars and different solar system and so on and so forth. So if you are interested, you should go to astrophysics. Okay. So I think I'm done. Any other question? There is a mention that Allah subhanahu wa ta'ala has said that there are 7 heavens created above earth. Okay, this is very interesting question. Okay, so what happens? There is an idea. The idea is like this: whenever you are given some information, you can actually understand the information, take some benefit out of it. And if you are not able to take benefit out of the information, what you should do? You should simply take it and forward it to the next people, next set of people, and so on. Okay, so in Quran and Hadith, there are so many things which people have not even understood till today. And I'm pretty sure there will be something which will be like people have not understood even till the day of judgment. Okay, so there will be some aspect of it, and this is one of them. So people have tried to explain it, and I mean, there is no proof to their explanation. The proof of the explanation will come when we actually go there and see the heaven. That will be the actual proof. But while living in on Earth and living the solar system, and then making guesses about the 7 heaven and 7 earth. It is just a guess. Now, having said that, this is just a guess. There is no proof. I mean, if I say this is the 7 heaven and this is the 7 earth, there is no one who will come say and say that yes, what you are saying is correct. Okay. So there is no proof. Still, people are making guesses. So I have also another kind of thought process around this. So now, I mean, we have seen one solar system where the sun is the center and then other planets are there. Then like that, there are so many other solar systems. So our solar, the group where our solar system lies, we call it Milky Way. So there are other Milky Ways, that is called galaxies. Okay. And then combining a lot of galaxies, this becomes something else and so on and so forth. And everything combined together is our universe. The universe where we are living. Now physicists are giving a concept of multiverse. Multiverse meaning like our universe, there will be another universe. Okay. And that universe will have all everything like galaxies, Milky Ways, and so on and so forth. There will be. And multiverse does not mean two. There may be more than two also. So this is the concept of the physicists that people are doing giving today. Okay. Why it is happening? They want to actually prove some of the findings they are actually seeing or observing. Just to prove their findings, they are doing it. Along with that, there is a concept of dimensionality. So this word that we can actually sense, it is three-dimensional word. Now adding one dimension is the time dimension. So if you add the third dimension as a fourth dimension as the time dimension, so essentially human, we can perceive only 4 dimensions. General people can understand only 3. If you little put some more effort, you will understand 4th dimension as well. However, if it comes to 5th and 6th dimension, I mean, we cannot even perceive this. But then, which is say, if your dimension is more than 4, there is a possibility that you are living with your twin and you don't know actually. So, and there is a aspect that if your dimension is more than that, then other kind of people, not people, but other kind of living things are living with you. You do not even sense that. So, I mean, for us as a Muslim, we can say, okay, like Jinnat and Shayateen, they are also there, but we cannot see them. And from the dimensional concept, we can actually understand, okay, if the word is of that dimension, they can coexist. We cannot see each other. Those kind of things are there. But it is, as I said, there is no proof. These are all theories. No one has proof. So when we die, we actually go to heaven. We see the heaven. We can request Allah subhanahu wa ta'ala to show us the 7 heavens. And if he agrees and shows, then it will be a proof. Hope that answers the question. No, science people, let me tell you like what is the science. I mean, see, it's all about people only. Okay. So what people observe and what people, let's say, as a science. So what happens is, earlier people have given this by nature, they have given this curiosity, something called curiosity. I want to know why this is happening. So this, curiosity, which is actually inbuilt in human being, this curiosity is forcing people to think. And that's how they understood so many things, just by thinking and observing, and trying to explain why it is happening. So basically, science is about nature. What is happening in nature, why it is happening, and try to explain is all about science. Now, what people will do in science is essentially, earlier it was like individual efforts. Now it is collective efforts. People in universities, the laboratories, they will be putting their time and efforts. Okay. So now since it is time and effort, it is money, there is an intention attached to that. And now science is towards something which is good for people, which is good for business, which is good for countries. That is the kind of a motivation now we are working. Okay. So so you can say like it is not free, like everyone just thinking and doing something. So if what is your motivation, that actually most of the time it governs what we are going to discover, where you are going to put your effort and time. So probably there is no intention, or you can say motivation, to prove that whether it is there are 7 earth or 7 heaven and so on and so forth. Probably if someone puts a lot of money and put a lot of people to just discover this using all the machinery that is there, maybe they can find some clue. but frankly speaking, I don't see like someone will be having even interest to just to see and prove that whether it is 7 Earth or 6 Earth or whatever Earth is there. So it is all about motivation driven. If you have people have motivation, they spend time and money, probably they can discover some of it. So that is my, you can say, my thoughts only. Again, I mean, you can completely disagree with me.
Thanks a lot, Dilshad bhai. Very informative session. So I think that's all we have for today. So
Yes,
thanks to
thank
all
you
the
all.
audience also. And it was really nice and very interesting also to listen to all these new things for all of us. So with this, we close this session. And inshallah, we'll keep on having further sessions. So if any of you want to share your knowledge on this platform, just let us know and we'll arrange your webinar also, inshallah. So with this, we close this session. Assalamu alaikum.
First of all.